Hi, in this video we're going to take a look at dividing and specifically dividing polynomials. But before we get into the dividing the polynomials, I just want to look at dividing some numbers or looking at some fractions here. Now I think in this first example most of us would just go through this. We'd add our 21 and 35 together and get 56. So we'd have 56 divided by 7, which ends up equaling 8. Correct, yes, it is. Now I want to show you a couple other techniques as to how we can do the division in this problem. Another way to look at this would be to look at this and go, well, 21 and 35, I see both of those have a factor of 7 in them, so I could factor the 7 out first, and if I factor the 7 out of the 21, we're left with 3. I factor a 7 out of the 35, we're left with 5, and that's still all over 7. Now, this is where I noticed, well, I have a 7 in the numerator and a 7 in the denominator, common factors. Those will now divide out. So if I divide those out, all that's left now is the 3 plus 5, and 3 plus 5 equals 8. One other technique that we could have used here is when we have a fraction like this, we can divide the terms in the numerator by whatever the denominator is. So I could take 21, which is one of the terms, divided by my denominator, take the 35, which is another one of my terms in the numerator, divided by 7. Now I look at it and go, well, 21 divided by 7 is 3. 35 divided by 7 is 5. Add those together, I still get 8. So a lot of different ways that I can show that the answer to that first one is 8. Now in my second one, the 10 plus 9 over 6, this one, like most of us would do, add our two numerators together, divide it by our denominator, we're left with 19/6. Now if I take kind of that approach that I did in the previous problem, I can't do that second one because there is not a common factor between 10 and 9, but I could break it into two smaller fractions, the 10/6 plus the 9/6. And then I could look at simplifying. Well, 10/6 is going to simplify to 5/3, plus 9/6 would simplify to 3/2. Now the problem with this is, though, now I'm left with fractions, and I'd have to find a common denominator to add them, so I just have to go right back to this to actually add them together. So that one wouldn't really help me simplifying that way. So there would be my final answer in that one. Now in my next one, 235 divided by 4, I'm using long division. And I want you to think back to how we used long division. In long division, we asked ourselves, well, how many times does 4 go into 2 to start off with? Well, the answer is it doesn't, not evenly. So then I'd go to my next number and go, well, how many times does 4 go into 23? The answer to that is 5. And then remember, we took 5 times 4, we put that 20 underneath here, and we subtracted. I actually want to get rid of this so it doesn't look like division. And then we'd have 3 left over. And then we bring down the 5, and then you ask yourself, well, how many times does 4 go into 35? The answer is 8. 8 times 4 is 32. If we subtract that, we're left with 3. So we could look at that as a remainder of 3. Now, we could have also looked at it as, since we had 58 as our answer, when we got to this 3 right here, we could have looked at it as a fraction of 3 over whatever we were dividing by 4. You could turn that into a decimal. We could have continued the division, but 3/4 we know is 0.75. So any one of those answers would be acceptable. And then my last one, I just have another long division, give us a little practice with this. 5 divided by 3, 3 goes in there one time. Subtract, we get 2, bring down the 0. Now we'd have 8 times. 8 times 3. I did that wrong, didn't I? Let's try that again. Well, 6 times. 6 times, there we go. 18, subtract, we're left with 26. Now, it'll go in 8 times. 8 times 3 is 24. We subtract that, we get 2, bring down the 1. And 3 goes into 21 7 times evenly, and in this one, there is no remainder. So a little practice on all of that. Now, the reason I did all of that is to help us when we actually start looking at dividing our polynomials. So my first example, I have a binomial divided by a monomial. Now, I have a little hint here, or a little reminder, based off of what we just did. There's that example from the first slide. Now, the reason I bring this up is because we can use this technique to help us solve this division problem. So what I'm going to look at is I'm going to turn it into a fraction. I'm going to take my first term, which is the 6u squared. I'm going to put it over 2u, minus the 22u over 2u. And when I do that, now I look at this and I go, I can simplify this term. 6 over 2 is 3. The u squared over u would just be u to the first. Then I go to that second term, this one, look at simplifying this. Well, the 22 over 2, that's going to become 11. U divided by u is 1. Put our subtraction sign in there, and we have it. One way I could have done that problem. Now, the other approach to this problem would be to look at taking this approach. So I'm going to look at what I have in the parentheses up there, the 6u squared minus 22u, and in that case, I look at that and I go, well, 2u is a factor. So if I factor out the 2u, now what's left is 3u, and then I factor a 2u out of the 22u, and I'm left with 11. It's still all divided by the 2u from here. And now when I go to this, I look at it and go, well, 2u in the numerator, 2u in the denominator, common factors, they're going to divide out. And now all that remains is the 3u minus 11. So it doesn't matter how we do it. Either way, we get the same answer. Now I have another one here. And again, I have my little reminder or my hint. This one goes back to that first problem. And in this one, notice I only looked at where we took each term from the numerator and divided it by the denominator. Now the reason I didn't put the other one in there where we factor, because I look at this, the first part of my problem, the 2r squared plus 3r minus 9, and notice there's not a common factor in there. So then what I'm going to do is I'm just going to break this apart into 3 pieces. I'm going to take the 2r squared, and I'm going to divide it by 3r. I'm going to add on the 3r divided by 3r, and then subtract the 9 over 3r. And now I'm going to simplify each one of these little fractions. So my first one, 2/3, there's nothing to simplify there. So I know I'm going to have 2 in the numerator, 3 in the denominator. R squared in the numerator, r in the denominator, simplifies to r. My second one, well, 3r divided by 3r is 1. And in my third term, the 9 over 3, that's going to become 3 in the numerator. R in the denominator, nothing else to divide out with that. And there we go. We have divided 2r squared plus 3r minus 9, all divided by 3r. My next one here is I have a polynomial, trinomial, divided by a binomial. And my little hint on this one is I'm going to go back to that very first one where I factored the numerator and the denominator. There wasn't anything to factor in that one. And if I look here, there's nothing to factor in my denominator here either. But when I look at it, I go, can I factor that first one? Yeah, I can. So I'm going to factor that. And I look at that and go, well, my factors are 2c plus 3 and c minus 1. So there's my numerator divided by, well, that c minus 1. So now I look at it and go, well, I have a factor of c minus 1 in the numerator. I have a factor of c minus 1 in the denominator. Those are going to divide out, and all that remains then is 2c plus 3. So we've done our division. And now I get to this one, which looks very similar to the previous one. So you're probably thinking, well, let's factor this numerator. Now you look at that a little closer and realize we can't factor it. So if we can't factor it, well, now what do we do? Well, then I'm going to give you this hint. I go back to that green one. We did long division. Well, we are going to use long division to divide these polynomials. And I'm going to show you how to do that. It's very similar to the techniques that we used in long division with our real numbers, but there's a little bit different twist to it. But we have to set it up. So what are we going to divide? We are dividing n squared plus 7n minus 15. And I want you to set it up like that. Now notice we have our n squared, and it's in descending order, and then the 7n, and then the constant. So I'd like you to write it that way. If one of those terms is missing, we need to add it in with a 0 in front of it. And I'll show that technique in a little bit. Now, what are we dividing by? We are dividing by n minus 2. So we come here and divide by n minus 2. Now, with long division, what we do is we're going to take a look at this first term. We're going to take that first term and we're going to divide it by just the n. We're going to ignore the minus 2 for the time being. And I ask myself, well, how many times does the n go into the n squared? Or what times n equals n squared? The answer is n. And I like to put it right above the n, I'll call it the n column there, just to keep it neat and organized. Now, like long division from over here, I now take my n and multiply it by all of that. What's that equal? Well, it equals n squared minus 2n. And then, once we do that, remember, then we subtract. We have to subtract all of this, and this is where you have to be a little bit careful. I like to look at it as this way. I'm going to go, well, I have the n squared minus n squared. Answer to that is 0. But I'm going to get rid of these because I'm starting to have too much stuff there. So the answer here, that part is 0. I don't really even need to write it down, but I will for right now. And then I'm going to go to my next one. Well, now I have to do what's 7n minus negative 2n. Now, that's where I said we have to be careful. Because 7 minus negative 2, that's really telling us 7 plus 2. And we end up with 9n. Right? Now, I'll bring down the 15 just so that it's here and ready to go. But then the next thing we're going to look at is we're going to look at, well, n times what equals 9n. Very similar to what we did over here when we got down here to the 35. We asked ourselves, well, 4 times what is 35? Answer was 8. Now, it didn't go in there evenly, but that's our step, and we're doing the same thing here. N times what is 9n? The answer is 9. So I'm going to put plus 9 up here. And then I'm going to do the same thing I did before. I'm going to take the 9, I'm going to multiply it by the n minus 2. And when I do that, I get 9n and then minus 18. Remember, we have to subtract that, and we end up with, well, 9n minus 9n is 0. Negative 15, remember though, minus negative 18 is going to put us at 3. So it doesn't go in evenly. Well, now that tells me that I have a remainder. So I can write this as, I could write it as remainder 3. I'm going to take the approach, so I'm going to write it in kind of fraction format. So I'm going to have to add on 3 over, now remember what we were dividing by, n minus 2. And there we go. So when it's all said and done, this right here is my final answer to that original division problem. And now I have one more here. Now notice I have a trinomial, but this time my trinomial has a p cubed in it. So p cubed minus 34p plus 45. And we're going to divide that by the binomial of p minus 5. Throw my little hint here again. Now in this one again, we have long division. It's just a little bit bigger. That's it. But the other technique in this one is, notice the p squared is missing. We have to add that back in. So I'm going to write down my p cubed, now here's the missing piece, minus, now this would be 0p squared. We don't have to write that, and that's why we didn't up here. Okay? And then minus the 34p plus 45. And then we're going to divide that by p minus 5. All right, here we go. So we start off and ask ourselves, p times what is p cubed? The answer is p squared. I'm going to put that over my p squared column. Now I'm going to take the p squared and I'm going to multiply it by p minus 5. I then get p to the third minus 5p squared. I now have to subtract all of this, which will put us at p cubed minus p cubed is 0. 0 minus 5p squared would put us at a positive 5p squared, because remember we did minus and negative. Now, the next thing that we're going to do is we're going to ask ourselves, well, p times what is 5p squared? The answer is 5p. So we're going to add on 5p. And then we're going to take the 5p and we're going to multiply it by the p minus 5. Well, 5p times p minus 5 is going to put us at 5p squared, and then minus 25p. My columns are getting a little off here. I'd probably like to slide this over just a little bit, because what I want to have it do is I want to have it line up with the 34p, because now I'm going to subtract this part right here. Well, 5p squared minus 5p squared is 0. Now I have to go all the way up here and look at this, that negative 34p minus a negative 25p. So I'm going to add 25p and end up with a negative 9p. And if you want, you can bring the 45 down. I did on the previous problem. This one I didn't. Don't ask me why. Just, I did it that way. A little different. Now, lastly, I got to ask myself, p times what is our negative 9p? The answer to that is negative 9. And now I multiply that negative 9 times the p minus 5. Well, I end up with negative 9p, and negative 9 times negative 5 is positive 45. And then I have to, remember, subtract this. Well, negative 9p minus 9p, that's 0. I got to go all the way back up here. The 45 minus the 45 from down here ends up to be 0. And I have a remainder of 0. Therefore, p minus 5 evenly goes into our p cubed minus 34p plus 45. And our final answer is right there. And that's going to end our lesson on dividing polynomials.